Good evening and welcome to the Q&A session 23 from the chapter of electric charges and fields. The topic is surface charge density and based on this topic I have one question for this session which is written here on this board. The question here is three concentric metal spherical shells of radius r, 2r and 3r are given charges q1, q2 and q3 respectively. So this is the figure which I have already drawn here in order to save the time. So these are the three concentric metal spherical shells of radius r, 2r and 3r, and this is the inner shell, this is the outer, this is the middle shell, and this is the outer shell. So the inner shell is given a charge q1, the middle shell is given a charge q2, and the outer shell is given a charge q3 as shown in this figure. It is found that the surface charge density on the outer surfaces of shells are equal. So the ratio of the charge Q1, Q2 and Q3 is. So we have four options here and we have to find the correct one. Now here the radius of the inner shell is R. The radius of the middle shell is 2R. And the radius of the outer shell is 3r. Now, in this case, what will happen? This charge q1, which is given to the outer surface of the inner shell, will induce a negative charge on the inner surface of the middle shell. So here, on the inner surface of the middle shell, minus q1 charge will be induced. And this minus q1 charge, which is induced on the inner surface of the middle shell, will induce plus q1 charge on the outer shell of the on the outer surface of the middle shell. So on the outer surface of the middle shell we will get the q1 plus q2 charge. So this is the total charge which will be generated on the outer surface of the middle shell. Now this q1 plus q2 charge will induce minus q1 plus q2 charge on the inner surface of the outer shell, and this minus q1 plus q2 will induce q1 plus q2 charge on the outer surface of the outer shell. So the total charge on the outer surface of the outer shell will be equal to q1 plus q2 plus q3, because we have given a charge q3 on the outer surface of the outer shell. So the total charge on the outer surface of the outer shell is equal to q1 plus q2 plus q3. Now the surface charge density of all these three spherical shells are equal. So we can say that now surface charge density is equal to the total charge which is residing on the surface divided by the surface area. So these are the spherical shells, so the surface area will be equal to 4 pi r square. So for the inner shell, the surface charge density will be equal to q1 divided by 4 pi r square. For the middle shell, the surface charge density will be equal to q1 plus q2 divided by 4 pi 2r whole square. And since the surface charge densities are equal, therefore q1 upon 4 pi r square will be equal to q1 plus q2 divided by 4 pi 2r whole square, and this will be equal to q1 plus q2 plus q3 divided by 4 pi 3r whole square. So from this relation, what we can do is, first of all, I will equate the first two that is, I will equate q1 upon 4 pi r square is equal to q1 plus q2 divided by 4 pi in bracket 2r whole square. So if I equate these two, then I will be getting see q1 upon 4 pi r square and here we have got 4 pi into 4 r square. So I will be left with 4 q1 is equal to q1 plus q2 by equating these two. So from here I am getting one relation, that is q2 is equal to 3q1. Now what I will do is I will equate this one and this one. So from here what I will be getting is this 4 pi r square will get cancelled out, and here I will be left with 9. So 9q1 will be equal to q1 plus q2 plus q3. Now here q2 is equal to 3q1. So I will be substituting this value in this equation. So I will be getting q1 plus 3q1 plus q3, and this is equal to 9q1. So 9q1 and this is 4q1, so 5q1 is equal to q3. So q3 is equal to 5q1. So the ratio of charges will be q1 is to q2. Now q2 is equal to 3 times of q1. 3 times of q1 is to q3. Now q3 is equal to 5q1. So if I divide this by q1, then I will be getting 1 is to 3 is to 5. So the correct option here is B, that is 1 is to 3 is to 5. So the ratio of q1 is to q2 is to q3 will be equal to 1 is to 3 is to 5. So thank you very much for joining this session. In the next session, I will be coming up with a different topic from the same chapter of electric charges and fields. So till then, have a nice day. Bye.